Thank you for being here. I just do a quick introduction to Professor QiangYang, who actually doesn't really need introduction. So I think many of our students have taken his class and worked with him even. So Professor QiangYang is currently the Chief AI Officer of WeBank in China, Shenzhen. He's the Chair Professor of CSC Department of HKUST. And he was chair of CSC department for many years. He's also the conference chair of AAAI 2021, president of Hong Kong Society of AI and Robotics, the president of Investment Technology League, and the former president of ICHCAI. His accolades, there are many, but he is a fellow of AAAI, ACM, IEEE, and AAAS. He's well known for his research interests in transfer learning and now federated learning. He is the founding executive of two editor-in-chiefs. He's the founding editor-in-chief of two journals, the IEEE Transaction on Big Data and the ACM Transactions on Intelligent Systems and Technology. He also published a book, latest books are on transfer learning and federated learning. So I actually had the honor of listening to many of his talks, including the one that was very memorable from the World Economic Forum in Davos in 2015. He's really good at explaining all these deep theories to an audience, and it's a pleasure always to listen to his talk. So we're very honored to have him today to give a talk on federated learning and its applications in the financial industry. And I should also mention that Professor Yang is also a advisor to our Center for AI Research at HKUST. So let's welcome Professor Yang. And you can reserve your question towards the end after his talk, then we can have a audience Q&A session. Professor Yang, I will stop sharing and you can share your slides. Okay, welcome.
Thank you, Pascal. So let me first try to share my slides. Okay, there we are. All right. Thank you very much, Pascal, and hello, everybody. Sorry to take your lunchtime. Hopefully, I wish to keep my talk relatively short, so we have more time on QA, which is more interesting. So, you know, the talk is on federated learning, which is a hot topic nowadays. Since we started this research direction about 3 years ago, now this area has flourished beyond our expectation. Now, almost all major corporations and industries, as well as major universities, have their federated learning teams, either in research or in deployment or in applications. I just received some invitations in hospitals in China and drug companies in China. They are interested as well. Just to give you one indication, in 2019, we published a survey, one of the first surveys on federated learning. Now the citation is over 700 on Google Scholar. So within the space of a year and a bit, this is an indication to show that why people are interested. So the reason why I say this is to bring your attention to show you that it's actually a good idea to sacrifice one of your lunches and come to listen to my talk. So let's go into this talk. I don't want to start the talk by speaking on some very broad areas and broad motivation. Let's just start with one very narrow application of machine learning on recommendation. As we know, when we are using our mobile phones today, when we are checking our videos, TikTok or whatever, the most important application behind the engine is recommendation. Okay, so for students, if you want to go into a hot area like a ByteDance or start your own e-commerce company, this is a must-learn recommendation systems. And so we have many applications like these. You know, I don't have to mention. All of them can do two things. One is they can bring a lot of products in front of you, and so they can recommend these products to you based on popularity. But that's not the end. The reason why TikTok is so attractive is because of the second thing, which is personalization, is individualized on your interest and zoom in on your expected interest. And even before you know it, can discover your underlying interest that's beneath the surface. And so we don't have to exaggerate this personalization technology, and this mobile phone gives a very viable platform to this AI technology. So alongside natural language processing, computer imaging, computer vision, and other technologies, recommendation is taking off. And if you ask what is behind recommendation technology, is it computer vision? Is it deep learning? The answer is it's actually reinforcement learning. Okay, and this is a less known technology in AI. And for this, you know, in the top conference called IJCAI, 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 there's a award that's given to a team of innovative researchers. It's Kominsky Award. The first award is awarded to AlphaGo. And we expect the next award will be given to the recommendation team. And so reinforcement learning. So what is recommendation? The mathematical model is very simple, right? So on the user side, we receive these recommendations, but deep inside the computer is actually a matrix that's being represented. On one dimension, we have users, as shown on the left. On the other dimension, we have products. So it's in the simplest mathematical form, it's a matrix. And inside the matrix, we have these values which represent user preferences on these products. If this user likes this product like a book very much, then we give it a score of 5. If another user doesn't like this particular book very much, we give it a low score, such as 2. If a user has not reviewed a product, that does not even know about the product, then it's empty. It is the empty cell that we are interested. Based on the known cells, whether a user likes it or doesn't, we want to guess or predict for those empty cells. And this is the mathematical problem of recommendation. Okay, and we can add more dimensions and add more data. So for example, we can make a matrix from 2-dimensional to 3-dimensional by adding location, space, time, and user groups, whatever. Okay, so that extends a matrix into a tensor. Okay, so that's an easy extension. Now, in recommendation technology, it is well known that the more data you have, the better the recommendation result. The result is evaluated based on the concept of precision. Precision is valued by, if I recommend 100 products to you, how many of these products are in fact what you like, okay? So for example, if 70 of the products you like, then the precision is at 70%. So this is very much like in search engine technology. But if I can personalize based on your search history, then I can increase the precision, okay? And so how do I increase the precision? Usually I try to bring in more data, either along the time dimension, I look further back or closer to real time, and along the space dimension. So I bring more seemingly irrelevant data and more data together, so I can bring them into the same repertoire. And so you can see on the right-hand side, the more data there is, we call auxiliary data, which means not the core matrix data, but something about the user, something about the products, and maybe something further removed, but eventually they will be useful. Okay. Now, so this brings us to the topic of federated learning. Usually these companies are hungry for data, but they are facing a major challenge, which is the shortage of data. They don't have so much data. And as we move along as a society, the availability of data is becoming more and more difficult. And this is not necessarily a bad thing, because the difficulty actually comes along with the protection of our privacy. So on one hand, we want to maintain our user privacy and maintain our human right. On the other hand, we wish to use as much data as possible. These two are fighting with each other, conflicting with each other. And so where do we strike the right balance? Now, of course, you can wait for the policymakers to give you room to live, and technology companies can increase the performance of your algorithm and becoming, you can hire better and better AI algorithm people. But the bottom line is data. If you can bring in more data, you don't have to hire so many talented people, and the performance can increase likewise. And the fact is we don't have so many talented algorithm people, but we have data there we cannot use. So what do we do with them? Now, so let me review our difficulty, our challenge. These news actually are very telling, right? So Facebook meeting trouble, Google meeting trouble, Microsoft meeting trouble, and all of these are because people are fed up with the unauthorized use of our personal data for some other purposes. And this is becoming such a problem that the society has really come down hard on the regulation of data flow and exchange. I just saw a day ago news from China that the Chinese government is forming a central data bank, which hopefully will help in creating the biggest data exchange market there is, and also regulate the use of data. Now, of course, when we hear about the word regulation, we frown. We think it's actually a clamping down on technology, but it's actually helping in relaxing the data monopolization problem. Right now, we know BAT has the biggest source of internet data, and they are not willing to share with people. These small and micro-sized companies are at a loss when they want to use more data. With the creation of a national bank, hopefully the situation can be more relaxed and data can actually serve in creating a better marketplace in the long run. But from technology perspective, not from policy perspective, what can we do? Can we just sit aside and wait until this kind of policy are taking place and just benefit from that? My answer is no, right? We have to do something to tell the policymakers that there are other ways, alternative ways to unite the data. And then they will have more tools in their repertoire when they formulate new regulations. And so the market will become more fluid. So there will be more freedom in flow of data. And so this picture here shows a lot. So say we have 5 data sources, and given the current societal situation, they cannot exchange their data, partly because the law, privacy law, partly because maybe they safeguard their data. They think their data is their property. They don't want to share with people, especially not sharing with people who are potentially their competitors. So there's a stagnation of data, and the market will die as a result. But we can look at the situation from a distributed computing perspective. We can consider that suppose each party can join in an ecosystem, and the ecosystem can form this data global model in a more equitable way. In other words, if I contribute more, if my data is more valuable, I can benefit from the global model more. If there's such a marketplace, then they are willing to contribute, and this global model can be built in such a way as to protect the data. Okay, so as I said on the right, first of all, the performance is lossless. So the model is as if all the data are together. Secondly, the raw data stays locally, and only the parameters or gradients are securely transmitted. They are not freely they are securely transmitted. So we can build this global model and share the benefit with people, with all the participants. Of course, this will be a challenge for technology people, but this picture actually summarizes what we want to do in federated learning. Okay, so back to recommendation. In recommendation systems, our data are basically in the matrix form, right? Remember, we have users and products, and now we have more data sources. So that means we have multiple matrices. Each data source has their own group of people, their own group of products. And so a question is how we can unify them without actually physically sharing these matrices together, and yet build something more powerful. Okay, now to do this, we have to have several necessary technologies. The first technology is secure computation. So there's this area has been growing along with computer science almost as old as 1970. It's called secure multi-party computation, and different encryption and decryption methods, different data sharing without revealing privacy methods. In database technology, there's a technology called differential privacy, which is a noising and denoising method to obscure the privacy of individual user. So all these can come to bear when we want to borrow from mathematics. Most of these are mathematics, have some relation with computer science, but most of them have been developed in the sub area of computer theory, computer science theory, and they have been obscure. They have been the toys of a few theoreticians until now, and we can bring them to bear. So more on this, right? So MPC, this term refers to the fact that multiple party can do various basic operations such as addition, such as comparisons, such as finding the maximum, such as finding the average without actually revealing their core data. Okay, and there are the famous problems such as the millionaire's problem. People can check Wikipedia for these references. There's also the technology which is ideal for this federated learning, which allows two things to happen. First of all, it allows encryption of key parameters of some models. Encryption that cannot be decrypted by other parties. So that's number one. So you can put a lock on a box. Second of all, the content of the box, that is what you encrypted, the parameter set, can actually participate in some important operations of the other party. So while the other party cannot peel into the content of the content of the package can participate in your operation, and you can update your model without knowing the content. So this is similar to receiving a package from, say, JD or from Alibaba. You don't open the package, right? The package contains some ingredient. You can use it for cooking, and you can cook your dish, but you don't actually know what's inside. Okay, just maybe inappropriate, but this is basically what homomorphic encryption does. Okay, now using this, of course, HE homomorphic encryption still has some drawbacks, such as being inefficient, although efficiency can be dramatically improved with algorithm progress and with hardware progress, like chips. And so people who are more theoretically and hardware inclined and network inclined can devote to this area, and you can see your future is very bright. But despite these, the technology has been limited to only polynomial computation so far. And so therefore, if we want to produce something nonlinear, such as using logistic logarithm computation, like logistic regression and so on, then you have to use something everybody should know, such as Taylor series, right? Such as other expansions, mathematical expansions. So go back to your advanced calculus and review Taylor series. It's very useful here. Anyways, so this is a perfect combination with the machine learning, because machine learning, many algorithms are actually nonlinear. But now we can do piecewise linear, so like the curve on the right. Now, so here I want to stress, some people may ask, if two parties only share the gradient of their algorithm, can they still learn the other party's privacy, the data privacy? The answer is yes. So here is a picture that shows this. If two parties are building a OCR, OCR means optical character recognition, which is very, very useful. Give a printed document, it can scan the document and get the word printed. Okay, so here's an O, which is the input. Now, by learning the gradient, the other party can reconstruct the input on the right. And so this, again, this shows it's a very dangerous thing. In fact, in 2019 NIRIPS conference, the best paper is by MIT team. The topic is called deep leak. Deep leak means when two parties are using differential privacy to communicate with each other, if they're not careful, if the noise is not noisy enough, then the other party can reconstruct based on the gradient information that is even Gaussian noised. The other party can still reconstruct the data. Okay, so this is called deep leak. Now there are various solutions for this, but I bring this just to bring your attention to the point that it's very important to be exact secure on the communication channel between multiple participating parties. And this is the reason why differential privacy is not widely used in industry, especially in federated learning. But it's still a very hard one. So students, when you go to Google Scholar and check on differential privacy, you can see thousands and thousands of papers, very high citation, tens of thousands on the citation part, but that doesn't mean that industry actually use it. In fact, because it's non-zero leakage possibility, industry actually embraces homomorphic encryption more. Okay, so this is the difference between practice and scholarly work. but as a student, you still have to devote on something. So differential privacy is actually a beautiful theory because you can prove based on a security budget or leakage budget, how much you are willing to sacrifice on your security. You can actually calculate how much noise you have to introduce or inject into your model. Now, regardless of the security, there's also the performance issue. By injecting the noise, differential privacy has a side effect, which is it degrades the performance. And in 2013, we have a paper when I was working in Noah's Ark in Huawei. We had a paper on BLDB to show that by introducing noise, actually that can render the model very secure, but at the same time, very useless. So you get a very secure package, but you cannot use it. So why get a package in the first place? But for students writing papers, it's still, it's a good practice subject. Okay, so we can go on and talk about this, but let me speed up a bit. So when we talk about federated learning, there are different paradigms of federated learning. The first paradigm is practiced by Google. So Google in 2016, as early as 2016, wrote a paper to support their Android system. What Google has is Google has a lot of mobile phones as the clients, and they have a central server. So it's a server client situation. Each client has some local data. Now, before, when they want to update a global model, they have to transmit this data to the server, but that reveals the local private data to the server. And if the server has some people irresponsible, then you have an information leakage. So this paper we call horizontal federated learning deals with this situation by allow securely exchange of not data, not raw data, but encrypted model parameters. And so the result is all the mobile phones can keep updating their local models. Why do mobile phones require their local models? When you use TikTok, use a local model. When you use face recognition on your banking software, you have to update the local model. So there are many local models, AI models now run on the mobile phone. So they every day they need updated. And so you can update models on your local phone without having to send out your local data. Okay, so this is the advantage of horizontal federated learning. Vertical federated learning is championed by us since 2018 after I started this team at WeBank. So it allows two organizations, maybe they are doing similar business, maybe they are doing different business, but they have a desire to share their data in order to extend their feature space. Okay, feature space means, so in our matrix model of recommendation, it means the product dimension, not the user dimension. The product dimension corresponds to the feature space. So now when we talk about natural language processing, the hottest model is GPT-3, okay, for people in this area. And there, the model parameters basically is on the order of 10 to the 11th, 10 to the 12th power, which is equal to the number of stars in our galaxy, which is basically equal to the number of neurons in our brain, which is very powerful. So that means we have to supply almost an equal number of features. So that brings us to the importance of feature space. So therefore, these organizations have a strong interest in extending their feature space of their data. Okay, so maybe my company only has data about being a financial company, maybe we only have data about users' financial credit, but another company, an internet company, may have data about the purchasing payment. Maybe yet another company may have more data about the user's travel habit. So all this putting together extends the user's feature space. And so vertical federated learning right now is flourishing beyond this mobile phone application, whereas horizontal are mostly within the realm of mobile phone applications. Okay, so let's go back to recommendation. So in both horizontal recommendation and vertical recommendation, we can formulate a federated learning version. Okay, so so let's first look at the horizontal version. So remember, in horizontal version, we have multiple mobile phones. Each phone holds local data. So party A is a person, and this person has chosen to rate some products, so has some ratings, but for most products has missing values. Similarly, for party B and party C. Now we want to make use of all their data in order to construct the global model in a central server. And how do we do this? Update the global model without having to upload the local private data. Now, so the mathematical formulation of the idea is that we can actually take each user data and decompose using linear algebra. So that goes back to advanced calculus again. In university years, linear algebra is very, very important. So we can decompose a vector into two matrices and into their products, a user matrix and a product matrix. The user matrix represents the local user's interest, and the product matrix represents the eigenvectors, that is the important dimensions representing the products. So if you have, say, 1 million products, maybe you have only 1,000 clusters of products that are actually different. And each of these clusters is represented by an eigenvector. And so matrix factorization allows you to do this. And so, okay, so once we do this decomposition, then it becomes clear how we can reconstruct the global model using horizontal federated learning. And so here is a picture. Suppose we have multiple users. Oh, and here you can see the adjective honest. So this is assuming that the users are not bad people. When they are bad people, what do bad people do? They try to alter their data in order to benefit from it. So when the global model makes use of the local model's parameters, it can be misled in order to bring more benefit for this bad individual. So let's assume that no such things happen. Everybody is honest. So what happens is they can form their local model and compute their local gradient. They can encrypt their local gradient and transmit it to the server. The server has no way of decrypt using homomorphic encryption, but they can bring together all these packages and use that to update their global model, and then distribute the global model. So once the global model reaches each individual user, they can be decrypted. So this iteration goes along. Of course, if we don't update, if we don't encrypt, then still based on deep leak theory, it's still possible for the server and therefore other parties to second guess any individual's data. So we can add a security layer on this by adding homomorphic encryption on this. And as you can see, by this keyword written in red, encrypted by HE. HE here means homomorphic encryption. And this paper has been already published in when? In 2019. Okay. Right. So people can check on this. But basic idea is this. Let's go to the vertical. Vertical case is two organizations. So let's assuming that it's again two mobile phone companies or banks working with each other. And when they work with each other, we still rely on matrix decomposition to do this work. And so what we have is we have a user matrix and the product matrix. And now, in fact, it is the product matrix that we want to learn. Okay, the user matrix are pretty much the same in this case, because we assume that the two parties share a large group of users, but it's the feature dimension that they want to extend. So therefore, they want to learn each other's feature space without actually leaking out any particular feature privacy. Okay, so this is the Q part of the matrix. Now, using this, we can follow the same process. We can encrypt the local gradient. We can exchange them. We can update the model, and we can go one step forward in updating their local model about the product space, the feature space. I won't go into details of this, but I can tell you that this thing has been used by many organizations, including within WeBank ourselves. We do a lot of advertisement, financial products, financial loans for small businesses, and here we make use of a lot of this. In fact, in TikTok, they started ByteDance has a team. They work on this as well. Okay, so again, this is the steps, and we can go and we can bring all these ideas together, horizontal or vertical, and formulate what is known as a federated factorization machine. So this machine can allow any joining parties to securely factorize their model and update either their local submatrix or their local product matrix or feature matrix. Okay, so we can form an engine to make this happen. This is a very preliminary area, and so if people are interested in doing more research in this, I think there's a very large number of topics, and people are welcome to come in. Okay, yet another area is this. Now, so far we have assumed that all the data are in the same format. They are matrix. What if one data is matrix, another data is picture, or one data is picture, another data is Excel? So this is called heterogeneous situation. So the data are in different format. Now we can add more complication to this. What if one data follows Gaussian distribution, another data follows Poisson distribution? One data follows one form of Gaussian distribution, another data follows another form of Gaussian distribution. Then machine learning theory assumes the so-called IID data, means identically distributed and identically sampled. Okay, but now it's not the case. Number one, the features are different. Number two, the distributions are different. And maybe the data are interrelated, so they are not independently sampled. So like in a graph situation, right? In matrix, we have many users, right? In a product recommendation. And what if the users form a social network? Then obviously they are connected, and the products form a product network, because a book is related to a book. They are closely related, but the book is less related to maybe cat food, okay, because they are different categories of products. And so products, so these samples are not independently sampled. In such situation, we need a new technology called transfer learning. Okay, what transfer learning allows you to do is to transfer from the original space into a different space. And in a different space, usually it's a subspace of the original space. There, we look for commonalities among the collection of subspaces. In such subspaces, we can still use machine learning algorithms and theories. Okay, so this is the idea. So transfer federated recommendation. Again, I have to skip a lot of here, and I won't go into details of this, but there has been a lot of work. You can see how early this is, 2009, on how in recommendation systems, you can use linear algebra to help finding the invariant in different data to help you with the transfer learning. And this invariant data actually corresponds to the subspace we are talking about. Okay, so let's skip the details and let's look at some applications. So this is in recommendation in the so-called movie lens. Movie lens is a testing domain for recommendation systems, which corresponds to many users, many movies, and many ratings. And so the recommendation we have done here is measured by the root mean square error of the final recommendation model on a reserved set of test data. And federated learning shows that it's almost as good as having the data altogether when you work with multiple data sources. Okay, now vertical recommendation here is combining a user's local private history data, the viewing history data, with the browsing behavior data on the internet. This is on one hand, it's browser data, on the other hand, it's mobile phone data, and they can be joined because they share a lot of users, but not features. Okay. Is there other ways to extend the technology? The answer is yes. Okay, so for PhD students, the frontier is not far from what you have learned so far. And one area I want to particularly point out is auto ML. Okay, so auto ML, so we know machine learning is from data to build models, and we measure it by performance. So we have these three things forming a task. Now, when we have this task, most of the process is actually carried out by engineers, and we call them AI people. And we know AI people are very scarce, very in short supply. And so our question is, can we produce an automated system to automate as much of the engineering process as possible and leaving people to only do a few critical things? And the answer is yes, because here, along with this workflow, we can see feature engineering, this middle step, third step, can actually be done automatically. Model training can actually be done automatically, and model evaluation can actually be done. So if you introduce any automated methods to do this, then you are said to be in the area of auto ML, automated machine learning. And so we are asking whether we can do something called auto FL, that is automated federated learning, because many of the participating parties may not have any experts in AI. And the answer is yes, you can do this. Okay, you have to trust me. You can do this, but I won't go into details on how to do this. Again, this area is very new. It's just starting, and we are practicing. As far as I know, there are some people in the University of Southern California working on this. There are people in the Fourth Paradigm company. This is a startup company in Beijing working on this, and we are working on this as well. AutoFL. Okay, so so let me skip. Okay, so let me go through the rest of the talk very quickly by going through in lightning speed the applications. So first of all, WeBank. So for those of you who don't know, WeBank is a mobile bank or internet bank. Actually, it's a mobile internet bank. By that, it means the bank is a virtual bank. It doesn't have any physical branches. So far, it has 270 million individual users. So about 1/5 of the Chinese population are using this bank. And this is for individual users. It's also a champion in helping micro and small businesses. Micro and small businesses means if you have a business with 10 people to maybe 100 people, it's a very small business, and usually big banks do not have VIP service for you. And so, and sometimes they face financial emergency. They have to apply for loan. They need some help with their supply chain. They need to deal with their inventory systems, and WeBank provides help for them. So far, WeBank provides help for about 3 million of those businesses, and in the China market, it's a leader in this. It's a market leader, and at the same time, the default rate are very low. A usual bank, if you go to any big banks, the default rate is about 5%. At WeBank, it's usually around 1% and even lower. It depends on how much risk you want to take. At that low level, it's a matter of you want to be aggressive or you want to be more conservative. So there's that issue as well. Okay, so this is the, so we have a system called Fate, which allows WeBank to formulate its credit risk models and use that to help with bringing down the credit risk. Right. In fraud detection, we have a form of home mortgage fraud detection, and using multiple data can help us extend. So this is all vertical, okay? Vertical federated learning, it extends the feature space, and therefore the model is richer, is becoming richer, and can bring down the default rate further. As you can see at the bottom, the AOC, that is the ranking performance, is increased by almost 10%, 9% here, which is a tremendous increase. In helping with the financial authority recommendation with the Chinese central bank, we have formulated a multi-bank fraud detection to detect anti-money laundering. So there are people who have some illicit fund, they want to make them into legal, and they go through a series of very implicit operations in banks and eventually becomes a legal fund. And so how do you detect that? There's no other way than bringing together multiple financial institutions and having a global model to detect the anti-fraud. And we are successful in that. And in fact, closer to home in Hong Kong, the Hong Kong Monetary Authority recommends using federated learning as part of their technology library. So this is the anti-money laundering application. The architecture is multiple banks forming a horizontal federated learning, and together the banking group working with internet companies forming a vertical federated learning. Okay, and in working with the risk management, and this is in China, in the mainland China, we are extending an ecosystem known as Federated Data Network. It's all financial data and alternative data that can potentially collaborate with financial data. And now there are hundreds of organizations joining this ecosystem. And so now federated learning is becoming a operating system uniting all these organizations in bringing up everybody's data efficiency while protecting privacy. So it's becoming a data level operating system. In insurance, it's the same story because insurance companies are interested in personalizing their models for decrease their risk, to extend their coverage, to do a better marketing. And so again, between different insurance companies, they can form a horizontal network, and between insurance industry and other industries, they form a vertical federated learning network. And here we work with Swiss reinsurance on this. And then the next series of applications is what about federated learning with computer vision? What about federated learning with speech recognition? What about federated learning with natural language processing? What about federated learning with reinforcement learning? In fact, either we worked on this, or we have encouraged others to work on this, or we have known others to have started to work on this. And so putting federated learning in collaboration with almost any topic in a machine learning textbook, such as computer vision, is a very, very rich area for PhD students to work on, like federated computer vision. This is federated supply chain management, right, okay, more federated natural language processing. And in COVID situation, by using federated learning together with a QR code, we can make sure that the information about any individual user is not leaked to any unnecessary parties, okay, because you can encrypt local data parameters. And the information about infection and whereabouts of individual user is only known to local client, this user, he or herself, or to the necessary authority, like the custom official. Okay, now between different hospitals, it's also a data silo situation today. Like different hospitals by law cannot exchange their raw data, but they are in very dire need to form an alliance in order to have a better global model. And here we worked with a collection of hospitals in Wuhan province in a global model to detect stroke patients for early detection, and using the checkup data, annual checkup of individual patients, and the performance increased a lot. Okay, continue with the speech recognition. I know there are many people working with Pascal on natural language processing and speech, and maybe it's worthwhile. So we are starting to explore but we have seen that using different language models located at different parties in a federated way is a very useful approach ahead. Okay, now, by the way, we are also leading in terms of forming an industry-wide standard. So the first standard is rolling out. It's called IEEE standard P3652. It's just approved as we speak. Yesterday, I got this email from IEEE. They say finally the executive committee approved this standard. So hopefully in May, you can see announcements in the media on this worldwide federated learning standard. Thank you. So that's all my talk.
Thank you so much, Professor Yang. That was a very, very educational and informative and rich, very rich talk. I wish we had more time. I wanted to listen to more. So let's open up the floor for audience questions. We have, okay, you can ask questions in the Q&A part. So here, the first question is, what are your major challenges during COVID-19? Does COVID-19 affect the prediction power of your models?
Right. So there are two answers to this question. First of all, COVID-19 brings the motivations for collaboration even stronger because people cannot meet with each other. They are in a so digitization is becoming accelerated as in every market like e-commerce and hospital services. And therefore, people are more willing to accept online solutions. And as a result, it actually helps in promoting technologies such as federated learning. The second answer is that COVID-19 itself also brings a dilemma. On one hand of the dilemma is performance in prediction. So you want to know whereabouts of this user in order to ensure that whether we allow this person to travel in the airport, to meet with other people, has this person traveled to some risky areas. On the other hand, we want to protect people's privacy. We don't want to want everybody to know everybody's whereabouts. So federated learning actually can address this balance. So it's helpful in terms of this. So that's why we see an accelerated moving forward in terms of federated learning research. Thank you.
Thank you. Second question, thanks Professor Yang for introducing how federated learning works in recommendation systems. About the bad debt rate of WeBank, I wonder how the federated learning or auto-federated learning helps decrease it. It seems like in fintech field, there are already too many mature techniques for this purpose. How does FL compete against these fintech tools?
Okay, so the short answer is the traditional methods are never enough. There's never enough technologies for decreasing the default rate. In fact, the traditional technology based on local data alone is not effective. And so that's why we are seeing many in China, it's called 暴雷, okay? That's why many P2P companies are using 高利贷, okay? If you can understand what that is, they are using extremely high interest rate trying to rip people off. So many of these are bad things in the society, partly because we don't have enough technologies to help with this. And one effective way is actually the most effective way is to unite as many data sources as possible when you build a model. So this is almost the only effective way to help with the financial industry is to use federated learning to bring in together as many data sources as possible in order to build the model. Yeah, so the answer is we don't have enough technology at all.
Thank you. Another question: to solve the federated learning communication problem beyond the model compression technology or technique, what other ways can we explore?
So right. So in fact, the federated communication issue, it's not necessarily model compression, it's model encryption. So you take parameters of the model, such as if you use logistic regression, you have weights for each individual features, and these weights are parameters, and you want to encrypt them and exchange. So what other ways are there in exchanging? There are many ways. For example, you can use GAN. So this is generative adversarial model, which is a new technology in AI to build a discriminative model alongside a generative model. So using this method, we can very genuinely, what we can do is this. We can build a mirror image of the original model. And this mirror image is a discriminative model. Its only goal is to communicate with the other party. And yet it allows simulation or mimic of the original model without actually taking the core private features of the original model. So it can protect the original model. So if we have a series of surrogate models or mirror models like this, we can actually prove that the security is increased. Of course, performance is decreased as well. So this is a very worthwhile technology, is to use GAN to help with the installation of the model you want to protect. There are many other examples. So I encourage students to explore more. And in fact, this is a very exciting area.
Yeah, you actually offer a class, right, to the graduate students here.
That's right. The class is ongoing.
Yes.
We have about 30 students.
Yeah. And perhaps next semester or next year as well?
Yeah.
If they miss this year.
Yeah. That depends on students' evaluation. If you all consider it's worthwhile, then we will continue. Yeah.
So another question. Thanks for Professor Yang's fantastic talk. Federated learning is very successful in financial field or recommendation systems. What do you foresee federated learning in healthcare applications in the near future, such as imaging, etc.? What are the specific challenges? Actually, I'm gonna dovetail on that question and ask you something similar in healthcare. So for example, recommendation of treatment, like for cancer patients. You know, we've long talked about treatment recommendation based on patient profile and patient or the cancer DNA sequences. But the biggest challenge there is that each clinic or hospital has its own database and they cannot really disclose them. So how can we convince them, or are you already in the works with the hospitals to apply federated learning in the healthcare industry in this way?
Yes, that's a great question. And in fact, on March 26th, I'm going to give a talk to Xiehe Hospital. And they are very interested in applying federated learning in medical diagnosis. And so in medical applications, there are two broad areas where federated learning can help. Number one is diagnosis, and number two is treatment, like Pascal mentioned. In fact, all these are, so we can further break down this area into the following areas. It used to be that one hospital can build a model to help doctors. But now it seems like it's inefficient, because especially in China, hospitals are usually specialized in something. So one hospital may specialize in medical imaging. Another hospital may maybe maybe in PCR, maybe in blood diagnosis of blood. So it's a question of how to join the results, diagnosis results of these hospitals together in a larger training data set. But on the other hand, hospitals are famous or infamous in sharing data. They don't want to share data. Nobody wants to take the liability. And so now everybody is looking into federated learning as a solution. Number one, it can help them in increase the diagnosis performance. On the other, it can safeguard the patient privacy. So this is, and so back to Pascal's question, treatment. A major feature in treatment here is personalization. So in terms of horizontal, so in fact, the Google solution is to have a global model, which is a general model working with each individual client, which has local data. And this is perfect for personalization. So taking a global model, taking a local model, and without leaking information, you can instantiate the general model locally. Okay, so we can use this for taking a general treatment procedure and personalize for individuals. So as an example, for any local, say, cancer patient, the method for taking a drug, put a certain drug, the timing may be different, the amount may be different, and the feedback method, that is the checkup method, schedule may be different. Each individual user may demand, in the future, may demand a separate treatment method. And in fact, individual treatment will become a future in medical diagnosis. So we can even imagine in the future, there is a separate cancer treatment medicine for each patient. And that really cannot be done without AI. And I think federated learning will play a role, although it's not the only technology, but it will play a major role.
Yes. Okay. Thank you. There's another question. Great talk, Professor Yang. What other challenges do you have when you want to scale the learning for millions of clients? Any difference when you have thousands to millions of users for federated learning?
Okay, good. This is a good question. In fact, even in the Google situation where they have several tens of millions, maybe 100 million level users, they cannot afford to go through this iteration for every single user. So they have to use a sampling methods in updating their general method. So now the issue is, who do you sample? How do you sample in order to extend the performance of the global model? And how do you sample and so if you want to avoid the adversarial users, so these are the so-called bad people who are there to eavesdrop your data or to in fact adversarially affect your model. How do you detect this behavior and avoid them being sampled? So there are many research issues here, and we are not there yet.
I see. Another question, can federated learning be used with blockchain technologies to achieve security and privacy goals?
Yeah, the answer is yes. And in fact, what blockchain does is it's very strong in auditing. So let's say if we are working together, students, say if 3 students are writing a term paper together, and in the end, there's always the danger of one student overclaiming his work. He will go to Pascal and say, I did all the work, the other students should get a C. What do you do then? The solution is to use a blockchain to record everybody's contribution. And so nobody can lie to Pascal, and Pascal can just check the blockchain. So this is exactly the situation. When different parties are working together, they work on a blockchain. So the blockchain records their individual contributions, the model contributions, and the testing result in order to attribute their credit, in order to fairly distribute the benefits of the model. So this by far is the most important ways in which blockchain technology can work with federated learning.
Thank you. I actually have a question, Professor Yang. So we heard a lot of this research issues and all that, but today, in today's actual world, how much of the federated learning is being applied, and to what extent, and what part of it, and how is it being applied?
Well, there are two camps, right? One is to C market, means to consumer market. Another is to B market, is to business market. So in both markets, federated learning is quickly expanding. Let me take one example. So some mobile phone companies, famous mobile phone companies in China are exporting their phones. So, you know, if you're a mobile phone company, usually you have a app store, right? You have Apple Store, you have other app stores. App stores have to work with any of the participating local phone users in order to update their recommendation models, right? When you open the store app, you have a list of apps recommended to you. How is that achieved? That's based on your past history. And how does the server know your history? Well, there has been some exchange of data. But now this thing is impossible to do in Europe because Europe has introduced this GDPR to prohibit any European users' data from going to other sources without getting people's permission. So these mobile phone companies exporting to Europe are very eager to build their own federated learning team within their company. And they go out and they claim that they use federated learning in order to update the local recommendation models of their app store. And so this is just one example. In 2B, in financial, I believe financial is one of the first because this is a very critical areas where these institutions require more and more data in order to boost their credit rating engines. On the other hand, laws are becoming more and more strict in terms of sharing. But it's just one of the first. It's quickly expanding. So when you look around, I'm not sure in Hong Kong people use it, but in mainland, I can give you many examples.
Well, perfect timing. Is there any other question from the audience? If not, this is our time is up. And thank you so much, Professor Yang. And we hope to see you in person soon again. And I really look forward to collaborating on using federated learning in NLP and speech. So thank you again very, very much. And thank you to all the audience who's in attendance and those who ask questions. Thank you.
Thank you all. Thank you, Pascal.
Bye.
Thank you.
Thank
Bye-bye.
you. Bye.
Take
Bye.
care. Bye.
Bye.